All right, so for this problem, just summarize what we know so far. From the problem, what do we know? You can put in the chat box. What is the given information from the problem? Thank you, Aiden. Direction is 120 degrees at a magnitude of 6. Thank you, Lynn. Direction is 120. Okay. And hopefully you guys still remember what we learned yesterday. This is the notation of magnitude. Okay. And so then for me, I'm a visual learner, so I will sketch it and actually see where is the vector v on the xy coordinate plane. So when we sketch vector v, we treat it like in the unit circle. So I have this, and then vector v will be 120 degrees, so second quadrant right here. So this is 120 degrees in standard position. So then now, like I gave you guys a hint earlier that we will try to make this as a right triangle. So then I drop this down right here and make it as right triangle. So the x value right here and the y value right here, that will be the values that I need to write my component from. Okay, any idea how we start with it? What is the very first step we need to do? I'm pretty sure one of you knows what to do, because based on your work, I know you have the idea how to start with it. Figure out the direction. It's like 120 minus 180 minus 120. Find the angle of the triangle. Yes. So all of the ideas you just gave me, that means we need to looking for the purple angle. Okay. So let's call that angle is alpha. So we need to find a measure of angle alpha by 180 subtract 120. So I have alpha equals 180 degrees, subtract 120 degrees, and that gives us 60 degrees. Okay. So now we know the alpha angle is 60 degrees and is inside a right triangle. So by using that angle, the given angle, what do I need to label on my diagram before we actually start looking for x and y? What else do I need to label on my diagram? So look at my diagram here. Anything else that I need to label? Yes, thank you. So I can label the hypotenuse is 6 because we know the magnitude is actually the distance between the initial point and the terminal point. So or the other way to say it is actually the side length. So then because the magnitude of vector v is 6, therefore we know the side length, this side is 6. Okay. So now you know the hypotenuse is 6. You know one of the angle is 60 degrees. Is it possible for you to find x value and y value? Yes. Okay, let's talk about x value. If we want to find x value, how do we find the x value? Okay. So if I redraw the right triangle just by itself, I have 60 degrees here. I have 6. I have x. Sorry. I have y and I have x. So x will be the adjacent side and y will be the opposite. So in order to solve for x, I will use adjacent side with the hypotenuse side right here. And the trigonometry that get involved with adjacent and hypotenuse will be cosine. So yes, I appreciate those of you give me cosine. I didn't mean cosine too because it's adjacent and hypotenuse. Yep. So then we have cosine 60 degrees equals to x over 6, right? And keep in mind, cosine of 60 degrees is actually a number. So a lot of you guys get to that step and you confuse because you think cosine of 60 is a variable. But actually, when you put it into calculator, um, and when you put it into calculator, make sure you double check your mode is in degrees. So in cosine of 60 degree is a number, and then after that we can solve for x. So the other way we can rewrite as x equals 6 times cosine of 60 degrees. Anyone got the answer yet? Three. Thank you, Trương Anh. Thank you, JC. Thank you, Lynn. So x equals 3. Right? Similar to that, now we can find y, right? Thank you, Aiden. Right, we can find y now. Anyone knows what can we do to find the y value? Thank you. So we do the same thing. We have sine of 60 degrees equals y over 6. And I actually like the idea where you start with your prior knowledge first. So you start with cosine of the angle or sine of the angle first. Sorry guys. And then we have y equals sine of 60 degrees times 6. Okay, what do we get? Thank you, Trương Anh. Trương Anh got 5.17. Can someone confirm? Thank you, Sean. Okay, so we have. That's totally fine, Aiden. I'm not too picky about like if it's off like 0.002. I don't take out the point from it. Okay, so I'm totally fine with it. So I put 5.17. Or you can put 5.19. That's totally fine too. 5.2 is fine, but try to route to nearest 100. All right. So then component form will be 3, 5.17. All right, give you time to process the information and ask me question. Why is it 5.17? I got 5.17. I think if you put everything exact answer, like if you put 6 and then sine 60 degrees into your calculator, do all of them together, then you get exact answer as 5.17 something. Don't you? No? So how did we get 5.17? Oh, you mean 5.19? Okay, my bad. Okay. So sorry for confusion. It will be 5.19. But thank you for bringing that up. Okay, any other question we have before we move on to problem 66? No? All right, so before we move on problem 66, so that means we can come up with the formula from this problem. We can come up with the formula now. So for component form, we have x and y. Okay, so see on the side, comma y. So then for the x, how do we find the x? How do we formalize this problem? Anyone knows? So think about the problem we did for the x value. What did we use to find the x value? Cosine, okay. Cosine with what? Yeah, so basically you take magnitude, x value equals magnitude of vector v multiply with cosine of the angle, but note that this angle have to be in the right triangle when you sketch it. Okay, and then for the y value, we can have it as y equals magnitude of vector v multiplied by sine of the angle, but that angle have to be inside the right triangle when you sketch it. I mean, you can use the formula, or when you sketch it out, you can use your prior knowledge. You still can find x and y value. So either way, it's easier for you, will work for me. All right. Any questions so far, guys?